Welcome to our session. My name is Ross. I'm a senior software developer with 10 years experience in Java and Spring application development. I spent most of my careers in financial industry. I work with large pension funds in my recent careers. And this is Zhang.
Hello, everyone. My name is Zhang. I'm a senior software developer with 15 years of experience. Currently, I'm working at Ontario Teachers Pension Plan, which is one of the world's largest institutional investors. Prior to that, I worked at BlackBerry and C Technologies.
So this is a standard disclaimer. So all the views and opinions that we express here are our own opinions. They don't reflect our employer's opinions. So today, we're going to share our experiences with migrating all the legacy applications to microservices. We're going to talk about all the pain points and the puzzle pieces that we solved along the way. And we're also going to give some recommendations based on the lessons we learned so far. And also, we're going to talk about some future work. So at last, we're probably going to have 3 to 5 minutes for the questions. And at the end, we're going to list of terms and technologies that we mentioned in this presentation. So this is a timeline of our migration journey. Our journey actually starts from 20 years ago in 1996. So we used to have Smalltalk and RPG programs. So how many of you have used the Smalltalk applications? Okay, only a few. Yes. So our Smalltalk application has over 500,000 lines of code. It mixed with UI logic and business logic into this giant monolithic application. But that's the technology that we chose by that moment, and it actually still serves our business today. And in 2006, we started writing applications in Java EE technology stack. We use EJB2, SOAP, Struts, Wiki, JSP, Hibernate. This probably looks familiar with most of you guys. And in 2011, we started writing applications in Spring. We use Spring 3, Spring MVC, Spring Security, and JSP. And in 2013, a few developers were doing the research for our non-critical applications using Spring Boot 0.5. And a year later, we start doing the business applications POC using Spring Boot 1.0. At the same time, we did some POC using Doku. For those of you who don't know Doku is a Docker-enabled mini platform as service. So last year, we write our business applications using Spring Boot. So at the beginning of this year, we took several initiatives. The first initiative was we did several POC using Spring Cloud services. So we tried a Spring Cloud config server, client, Eureka, Ribbon, Hystrix, and so on and so forth. And then we deployed MicroPCF into our development environment. And then we deploy a few microservices onto Pivotal Cloud Foundry.
So technologies changes very fast. It's not so hard to apply them to new services. But how about our legacy applications? As Ross mentioned, so we had these 2 legacy applications talking to S400 database. And over time, our team started migrating or rewriting some of the business logic from Smalltalk to Java EE applications, and then reroute the process from Smalltalk to Java applications, running on this application server. And then we migrated more and more business logic. And we started leveraging the features provided by this server. Why not? And we added more servers to scale. And here we found some pain points here. So all of the pain points fall under these 3 categories. Now they are painful because they prolong the feedback loop. As a developer, I would rather spend my time on coding real business logic than infrastructure setups and so on, as mentioned in the keynote this morning. So now the first pain point is that it takes too long to set up the development workspace. As a developer, I need to download, install, even configure this application server on my local workspace. And usually that takes like 5 or 6 hours. Another pain point is about jar hell. So, because every service depends on hundreds of third-party libraries, and it's a headache to maintain the dependencies. Now, framework configurations. So we used to define the framework configurations in XML. Again, nobody likes XML so far, so that's the other pain point. Once we finish development, we need to deploy. Years ago, we used to manually deploy our application to this server. It was painful, it was long time, it was inconsistent. And then our team came up with scripts to automate this process, which is great. Now it takes only 5 minutes. And we started doing more and more. However, we found even more problem. So as a matter of fact, we found this application server is too unstable to deploy multiple times, not even 10 times a day. So downtime is another problem. It's destructive to bring down the service and deploy, and it's very hard to script the zero downtime deployment with this application server. Now, once we deploy, we need to operate, of course. Most of our applications didn't have health check before, so it means that when something goes wrong, it's always our customers or end users who call us to, and it's already too late to respond. Now, if we could respond quickly enough, that should be okay, but unfortunately, without enough log aggregation, our turnaround time is maybe several days after our analysis. So our team started working on the solutions, and we were going to build some independently deployable services. And this is when this term became popular, microservices. Martin Fowler said it very well, and we didn't even realize that we were doing this. So when we look back, I think our team was very pragmatic. We didn't do what's popular out there. We focused on our own problems, and we worked on our own solutions. So during our migration, this is the list of puzzle pieces that we want to share with you guys. Starting from zero, of course, we're Java developers, so everything starts from zero. This application server shows up again in our pain points. And how did we solve this?
So because the application server is really slow to start, and also every developer needs to configure its own local workspace to run this application server. So that's why we first tried to put the application server into Vagrant managed virtual machines. But then we found out the Vagrant managed virtual machines take too much resources. And then we start putting the application server into Docker containers. So Docker container itself is actually pretty fast to start up. But then the application server itself, you have to wait like 5 minutes until it's finished. So it's still a pain. So that's why we thought about how about we use a standalone Tomcat. So the good thing about standalone Tomcat is less complex. You don't have to be an application server expert to configure Tomcat. But then because we use some application server features like messaging or caching, standalone Tomcat doesn't have all those features. So that's why we need to set up a separate RabbitMQ for the messaging, and we use EH cache in the caching layer. But eventually, we went to the embedded Tomcat approach. So the good thing about embedded Tomcat is you can isolate your application deployment within that application itself. So it isolated with other applications. And also, it's easy to script. So you can pass in different parameters. So that further enables the deployment automations. As a result, we have cut down the local setup time from almost 5 hours to 0 seconds, basically. And we cut down the deployment time from 5 minutes to just 1 minute.
So the next puzzle piece is about the boilerplate framework configurations in XML. So how do we solve this?
So because we used to have many XML configurations, so nobody likes XML, or sometimes we end up with 1,000 lines of XML configurations. Developer needs to dig into these XMLs. And we migrated some XML configurations to Java config. But then the problem we found with Java config is you still need to know which class that you need to use. For example, your data source and the Hibernate. You need to configure the data source first, and then you need to configure the Hibernate local session factory. So that's kind of challenging for developers, and it requires some like digging into the documents. So we use Spring Boot. Because Spring Boot is using the convention over configuration approach, so we have successfully reduced the XML configuration, 30 lines of XML configurations to just 3 lines in the application.properties.
So next puzzle piece is dependency management. Now this is the snippet of one of the poems that I used to maintain. So I need to make sure that every single version of the third-party libraries are compatible with each other at compile time, at runtime, also compatible with the application server. So this was a lot of work for myself. I spent hours on it. I would rather, again, spend time on coding business capabilities. So how do we solve this?
So that's why we use Spring IO platform. We are using Maven and Gradle to manage all the dependencies, but you can imagine there are so many dependencies in one application. And for example, we had a case that we upgrade the Spring and the Hibernate version number, then we're having the runtime conflicts with the Spring with the Hibernate validator, so that we need to spend lots of time and effort to make sure like all those dependencies work with each other. So by offloading all of those work to Spring IO platform, it gives us the confidence that all those dependencies can work together. So right now, if we want to add a dependency into our project, we just add a dependency into the dependency sections without specifying the version number. So the Spring IO platform can guarantee all those dependencies run together.
So the next puzzle piece is about monitoring. So we actually had these 2 issues happening in our production environment. So randomly, we found the murder mystery to our application, and okay, we just do the brute force restart. Sometimes it works, sometimes it doesn't. Another issue we found once, the production app actually depends on the dev environment. So this is all because that we were lack of the insights of the applications. So what's the solution?
Because we want to know the inside of our application artifact deployed into our production environment, so we use a Spring Boot actuator. We not only use a Spring Boot actuator standard endpoint, we also did some customization and extensions. So for example, the /health endpoint, we combine it with Sensu. Sensu is our monitoring system, so that the application, the operations people can get notified right away if something goes wrong. And another example is a /info. We did some extension from it. As you may heard this morning in the keynote, we actually so with Spring Boot 1.4, it comes with like a lot of more information than the to expose in the /info, like your git commit, your git shard, like something like that. We actually did before the Spring Boot 1.4 release. So this /info exposes the build number, the Maven artifact ID, timestamp, git commit shard, so on and so forth, so that it can link back to our CI build pipeline. Then we know how it was built, when it was built, and how it was tested. And we also did we also expose a /dependencies as our own endpoint. I'll show you what it does. So this is /info. This is a snapshot of /info. You can see here expose everything in JSON format. It exposes the Maven artifact, it exposes a git branch, git commit ID, and build number. And this is a snapshot for dependencies. So we expose it in JSON format as well because it's easy to parse. For each dependency in this dependencies, we expose the service name, version, and endpoint. So you can imagine under the microservice world, one microservice can depend on many other services. And you need to know like all the dependencies information. So you can think about this as a static dependency information for your microservice.
So the next puzzle piece, to be fair, we didn't have these 2 problems back with monolithic applications because we only had 1 or 2 configuration back then. And we don't need to trace the request and response because everything was deployed as 1 unit. Now with microservices, we found that our configurations are isolated with or without security. And it's really hard to trace the request and the response bouncing between those services. So what's the solution?
So what we used to do is when the application deployment happens, the deployment script download all the configurations from the Git repo and then put into a config folder on the server. So when the application starts up, it will search the application.properties in the config folder. So that's actually already a step forward from putting everything into the WAR file. But then we found each application needs to manage its own configurations. And also, even though we have some proper access control on the GitHub, but then we don't have access control on the config folder on our server. So that's why we try to use Spring Cloud Config Server and Client to centralize all the configuration management and also secure our configurations. So for the second problem, we tried using Spring Cloud Sleuth and Zipkin server to do the distributed tracing and logging. But when the time that we tried it, Spring Cloud Sleuth was still in milestone version, so it was not stable enough. We have to tweak some dependencies to make it work. So that's why we feel like we cannot use it in production.
So build pipeline is essential to microservices. We do have one. So back in 2013, this is our build pipeline looked like. We make a change in our local workspace. We make it commit to a master branch. We kick off a build on CI server to compile and run some tests. And then we deploy that change to the staging environment for our QA team to verify to do some interactive tests. Once they approve it, we'll deploy that to production from someone's desktop. Now, this is simple, and we found that it didn't capture the deployment issues. So we did some improvement. We added a stage called automated infrastructure test. We're using Chef to do it. So at this stage, we use Chef to spin up a Docker container and then install the application inside it and then start it up. And then we also use Chef to verify if the /health actually works. If it does, then destroys the container and it succeeds. We also worked with operation team to do the one-click deployment to production. And still, we can do better.
So we don't stop at the automated infrastructure test. We incorporate the Pivotal Cloud Foundry into our build pipeline. So why we chose Cloud Foundry, the first reason is it uniforms the deployment process, regardless of framework that it's using. And the second is it has the easy zero downtime deployment. And also, it has the self-healing features. For example, if you want 3 instances for your applications, and you just specify the 3 instances, and if one of the instances is down, the Cloud Foundry will actually automatically detect that instance is down. It will spin up the instance back for you. It's all done automatically. So that enables all the automations for our operations people. So that's what we call like a true one-click deployment in production.
So this is my favorite. We're creating new services every month, if not every week or every day. We found that for each new service, we need to create a couple of Git repositories, a couple of plans for deployment or build, and then we need to create the scaffolding codes, tests, README, changelog, YAML, RAML, POM, whatever you name it. So this is a lot of work. Guess what our solution is?
So we have the spring bloomer. Probably it's hard to see here, but there are some blooming flowers at the thing. So this idea was inspired by Spring Initializer. So if you are a Spring developer, if you want to create a new service, the first thing you'd probably do is go to start.spring.io. You select a bunch of dependencies, you click generate, then you can start working on your code. So we're having a similar approach. We extended from the Spring Initializer, but we did more than that. Not only we can search for all the dependencies, but also we did all the code templates, predefined dependencies, and actually it set up the GitHub repos, and also it can set up the Bamboo plans. So it will also set up the webhooks. So when it's generated, it will actually trigger a build to make sure everything works. So this is a screenshot from Spring Bloomer. So when we did Spring Bloomer, we thought carefully about the trade-off between the freedom to search dependencies like you can do in Spring Initializer and the consistency among different projects. So that's why we only allow developers to choose the project type, what type of project you can work on. So each project has its own predefined dependencies. So after that, you specify the project name, which is very important because it's going to be your Git repos name and your Bamboo plan name. And also you fill in the description, version, and you can click whether, you can choose whether you want to include working examples, test files, so on and so forth. After you fill out all those information, you click generate project and wait for the magic to happen. So after it's done, it will generate some example code and also the configs in the config repos, and it will set up the GitHub webhook to talk to the Bamboo plan. And also all the Bamboo plans, all the steps already set up for you. Let's take a look at what it looks. So as you may notice here, so we have a bunch of files. We have like different layers. The code structure is already there. And for the config, we use a Git sum module. It links back to another Git repos. So that helps us easy to manage all the configurations. And also you may notice there's a manifest.yaml file because we're going to push the application to Cloud Foundry. And also in the pom.xml files, we already specified the predefined dependencies. And not only that, we also generate the changelog and the README files. So that saves a lot of work for developers because developers probably don't want to write all the documents and stuff. So this is really awesome.
So if we look closer to the tree structure of the repo got just generated, as you can see, the application has several layers like domain layer, service layer, or WS layer. And each layer contains the code, some code, as well as the unit tests. And in the service layer, you may notice that we're using Spring Data to do the database integration. And in the WS layer, we also generated this RAML file to describe our REST APIs. So RAML stands for a REST API modeling language. Some other options could be Swagger or Spring REST docs. So this is a lot of work. And yeah, it has 49 directories, 32 files. Now, Spring Bloomer takes care of this for our developers. Also, this contains some of the conventions, like coding standards inside, so that it's easier for our developers to follow those conventions. So this is the Bamboo build plan generated by Spring Bloomer. And it also got actually triggered and executed once with 9 unit tests passed. We also actually generated end-to-end tests, but we agreed that E2E is too slow to run in this plan, so it will be in a separate plan. And this is the webhook set up by the Spring Bloomer. Now, this is the configuration repositories. We externalized our configurations so that we only need to build the artifact once, and we run that artifact in different environments using different Spring profiles. So all of these solutions and works are awesome, especially the build pipeline improvement and this Spring Bloomer. It takes people a long time to come up with this. We wouldn't have done this without some organizational changes.
So this is our organizational structure as of 2013. So it's pretty like a standard organizational structure in most companies. So we have dev, we have QA, PM, business working on each different projects, and then we have operations people support all those different projects. And then we add a DevOps team to our organization. So what DevOps team does is to increase the developers' productivity tremendously. And also, it automated our infrastructures and codify our standards. It helps our operations people as well. So we found the DevOps brings a good value to this organization. So here we want to share our experiences and some recommendations based on the lessons we learned so far, because we hope this will be useful for those of you who are in the same shoes as we were. We feel like Spring Boot is the baseline, because Spring Boot provides many neat features like Spring Boot actuator, convention over configurations, and also so all these features, and embedded Tomcat. So all these features enable us to transform all those legacy applications to microservices easily. So without Spring Boot, we cannot imagine that we can do it so easily. So the second lesson is to enable the test automation as much as possible. So we have different levels of test automations. We have unit tests, we have integration tests. We also use the Selenium for the end-to-end test. So all those different levels of tests give us the confidence when we do the migration. Last but not least, we feel like health and monitoring is super important in production, because so the operations people get notified immediately if something goes wrong, instead of an angry customer calling us. And when it's combined with the logger aggregation analysis, the troubleshooting becomes easier for developers, because what usually developers will do is they log into different servers, they check the logs, then troubleshoot the issues. But now, combined with all those tools, developers can go to a single place to troubleshoot all those issues. And think about how to define a healthy application. We actually had some debates over like what a true healthy application means to us. So we define it as all the dependent services for this application. If they are healthy, that means this application is healthy. So please take some time and think about how to define yours. And lastly, please secure your Spring Boot actuator endpoints, because we had an incident that during the deployment script call a /shutdown endpoint in the production application. It just shut down the application in production. And you don't want that happen to your application. So even though we have migrated the applications to microservices and deploy them on Cloud Foundry, there are still some future work that we need to do. First is log aggregation. Even though Cloud Foundry provides good facilities for the log aggregation, but we need to configure our log and analysis tools to consume all the logs. And because we only have a few microservices right now, we don't find the value with service discovery and client-side load balancing. But after, if we have more and more services, we may use Eureka as a service discovery, or the Ribbon and client-side load balancing. And for the A/B testing, we simply don't have a business case right now. So please let us know if you have any questions. And this is a list of all the terms and technologies that we mentioned in this presentation. Thank you very much.
Thank you.